Start recording. Okay, so these are the questions that we'll be looking at. All right. So yes, so this is a question solving session. So let's just jump into it. Okay. So in a certain factory, 3 conveyors, the sand conveyor, the gravel conveyor, and the main conveyor are in operation. The main conveyor, so these are the conditions for the operation of the factory. The first is that the main conveyor must be in service before any other 2 conveyors can work. Number 2, the gravel and sand conveyors must not work at the same time. What this means is that it's either you have what? You have, so the main must always work. So main plus gravel or main plus sand. Except before the gravel must come on, the main must always be in the circuit. And before the sand must come on, the main must always be in the circuit. So let's see. Now, the conveyors can be started by means of their respective push switches. So they have their respective push buttons, and then they have their respective overloads and their respective stop buttons. So the question says that, which of the following correctly describes the operation of the main conveyor? Let's see how we can do with that. So I said we use an SR latch, right? SR latch. I have my kill here. So first, let's see. We are dealing with the main. So let's see the output for the main. So main conveyor, what's the output? Main conveyor. The kills are the output, as are input. So main conveyor is kill 0.1. So this is kill 0.1 here. Now, I said that the S or the set is what will always make the output come on. So let's see. If I have this here, how the main conveyor come on? Is by pressing the main start button. Once I press the main start push button, I press it to come on. And how will it go off? It will go off either when I press the stop button or when the overload trips. That's when the main will go off. So that's it. So you just apply that. So set to make it come on. So what to make it come on is when I press the main start button. The main, so it's when I press the main start button. I'll just close your eyes. Okay, so let me start from somewhere again. So I have the SR latch here. SR, we said the main was KO 0.1. What to make it come on is when I press a start button. So the main start push button is I0.1. And it will go off when either this is stop I0.4 or the overload I0.7 trips. So here I have my I0.1. Means when I press the main start button, here becomes 1, the output becomes 1. How will it go off? There are 2 ways by which it can go off. So it means I need an OR gate, right? It's either the stop is I0.4 or the overload trips I0.7. Remember I said that for the overload and the stop, you always note them. So let's see. So this means that when the stop trips, I get 0 here, it becomes a 1 here. And once I have a 1 here, I have a 1 here. Once here becomes 1, the motor will go off. So that's how so you always think about it that way. When I press the start, I have a 1 here. Once I have a 1 here, I get a 1 here, the main comes on. When the overload trips, I have a 0 here because it's tripping, it's cutting the circuit, so it's 0. I notice I have 1 here. Once I have 1 here, I have a 1 here. Once I have a 1 here, I get a 0 here. So for that question, So for that question, the answer is, so just go through and see, the answer is A. And see, and because it's MCQ, you can always just think around the answer, so it makes it a bit easier. Now the second question is, wait, am I recording? Okay, sound is on. 5 minutes thing. Second question is to describe the operation of the gravel conveyor. Now, let me get it. They said that for the gravel to come on, the main conveyor must be on, and then the gravel and the sand cannot be on at the same time. So let's see. So once again, I have an SR latch again, right? I have an SR latch here. KO. So the output is the gravel. Let's see what the gravel is. So the gravel is given by, gravel is KO0.3. KO0.3. Now, for the gravel to come on, some conditions must be satisfied. And usually on with an end gate. So we say that 1, the main conveyor must be on. Main conveyor. The main conveyor was what? So that the main conveyor output is KO0.1. So the main conveyor must be on. When the main conveyor is 1, I have a 1 here. Number two, the sand must be off. We say that the gravel and the sand cannot work together. So the sand must be off. Sand from the table is KO0.2, and it must be off. Let me bring a note here. This means that when the sand is off, it means I have 0 here. But then I'll note it to get a 1 here. So once I have 1 here, also mean must be off 1. And I press the gravel starting switch. The gravel start switch. The gravel start button is I0.3. I0.3. So now let's interpret this drawing here. When the main is on, I have 1. And the sand is off, I have 0, but then I'll notice I have 1 here. And I press the gravel switch, I have 1 here. Once I have 1 here, I'll get 1 here. So once all these conditions are met, I have 1 here. And once I have 1 for set, I have 1 for the output. The gravel comes on. Now, how does it go off? Let's see how it goes off. We said that for it to go off, it will go off when we press the stop button or the overload trips. But then, because the gravel must work only when the main is on, it means that when the main stop button is pressed or the main overload trips, it will go off. So overload and stop, you knot them. So there will be 4 knots here. 1, 2, 3, 4. So gravel stop, gravel overload will make it go off. Or when the main 2 goes off, it goes off. So main stop and main overload will make it go off. So let's see. So gravel stop, I0.6. Main gravel stop and main stop. So I0.4, I0.6. So I have I0.4, I0.6 here. Then the overloads. Gravel overload, I1.1. Main overload, I0.7. So I0.7 here, I1.1. So this is it. So let's check the answers. Here. So here, yes. So the answer is A. You can see it here. So the gravel switch should be pressed. The main conveyor should be on. The sand should be off. It means you knot it. That's how it will come on. And it will go up when either the main or the gravel stop or conveyor trips. So that's it. So see, it's not really difficult like that. You just have to know how to think around it. Like that. Okay. So let's move on. So the next thing we are looking at, let's take the operation of the sand conveyor. So let's see the operation of the sand conveyor. So the sand conveyor will also look like this. So the sand conveyor, so for the sand conveyor to work, what must be true? 1, the main must be on. The main must be on always. So main must be on means main is Q0.1. So Q0.1 must be on, right? Q0.1 must be on here. Also, the gravel must be off. Gravel is Q0.3. It must be off, so I'll note it. And then I'll press the sand switch I0.2. Once all these are 1, 1, 1, once here is, I'll get 1 here, I have 1 here, this will come on. Also, it will go off when either the main, because when the main goes off, the sand will go off. So either the main stop or the main overload trips, or the sand stop and sand overload. Sand stop and sand overload. Sand stop is I0.5, sand overload is I1.0. So I0.5 or I1.0. So that's it. So yeah, so after that you just so that's it. So you choose. So over here, you can see that the answer is B, right? They didn't add one. They didn't add the sand. They didn't add the main overload. Or you see it here. See it say Q0.1. So it means that Q0.1 means that what? When the main goes off. So here, when the main goes off, that's Q0.1, or sand overload or gravel overload. Okay. So here they put the main going off as 1. So the main going off is this. They just make the main go off. So this is what they did here. This. And said, okay. Q0.1 main going off. Q0.1 here. And that will make it go off too. So that's it. So that's it here. So as I said, always think of it process wise. Like if you were the machine, how do you run? Right? And then how do you go off? How do you come on? That's it. So that's it for this question here. Let's move on, please. Now, number 4. The figure 1 shows a simple relay control circuit diagram that can be used to control the forward and reverse movement of an induction motor and the corresponding connection diagram to a PLC. So here I have the diagram here, right? Now let's break it down. The question says that find the F functional block diagram for the output K1. So if you check here, let me increase the size. If you check here, the output K1 is the motor moving forward. And the output K2 is the motor moving reverse. Now let's see what will make this motor come on or move forward. It means that current must flow from here through here, right, and must reach here. The current has 2 paths it can take. The current has 2 paths that it can take. The current can come here, F1, S1, go through K1 and get here, or come here, go through this region here I'm circling this region here, and come here, right? So now, before the motor can move in the forward direction, so let's see. So here we use an end gate here. Okay. Now, if it's MCQs, once you look at the diagram, you know what they're using, whether they're using end gate or SR latch. So it shouldn't be a problem on whether I should use end or I should use SR. So first thing, the start. So this, if you check, now this S1 is a stop button. If I open it, the circuit gets cut off. So it's a stop. F1 is overload. So the first thing is that the overload and the stop must be in the circuit. Now check. The stop is what? I1.1. Overload is I1.4. So I must have I1.1 and I1.4 in the circuit. Kindly follow. Okay. Also, the motor can move in forward and reverse. So the motor must not be moving in the reverse direction. So it must not be reverse. Reverse is what? Reverse is KO4.2. So KO4.2 must be noted. It should not be reverse. It should not be reverse. Right. Now let's see. Now the second thing is to know that this switch here is open. You can check it's open. So I must close it. So it means I'll press S2. When I press S2, I'll get 1 here. Right. So check out something. So S2. So when I press S2, I'll get 1. S3 is already 1. So S2 is I1.1, S3 is I1.2. I mean I1.2 and I1.3. So I have it like this. So just pay attention. So when I press S2 and S3 here, I'll get 1 here, right? Let's understand this one here. Now this diagram here means that, let's see, it means this motor can move in the forward direction, which we know is KO4.1, through 2 ways. One, when I press S1 and S3, right? Once I press it, it means I have a 1 here. Once here becomes 1 and here is 1, and the motor is not moving forward, meaning I get 1 here, and the overload has not tripped. I have 1, and the stop has not been pressed. I have 1 here. I'll get 1 at the output. So that's it here. So when this is 1, 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 I have 1 at the output. Or you know that as soon as K1 gets energized here, it will close this K1 here. Whenever this is a contactor, this is a contact. Whenever a contactor gets energized, it changes the position of the contact. So this contact is normally opened. When K1 gets energized, it becomes closed. So the current can also go through K1, and K1 is what? KO4.1. So, or when KO4.1, which is that K1 there, becomes 1, it means I have 1 here. Once I have 1 here, I can have a 0. I can have a 1 at the output because it's an AND gate. So that's it. So that's the interpretation. So over here, the answer is A. The answer is A, as I've explained, right? So the stop should not be pressed. So the stop should be in the circuit. It should be 1. It should be allow power to flow through 1. Overload should allow power to flow through 1. Reverse should be off. So not it, right? Then when I come here, it's either that small key there is closed, or I press S2 and S3, and that's what will make current flow through. So the answer is A here. The answer can't be this, because there's stop and the overload, they must not be zeros, they must be 1. So the answer can't be this. This shouldn't be noted. And then also KO4, this is wrong because KO42 has to be off, so it has to be noted. This is wrong too because this has to be 1 for it to work. So the answer is A. So you see, you just have to always think around it. You have to always think around it. Now the next question. When a push button S1 is pressed, a supply main comes on and an industrial centrifuge runs at low speed. So let's see. So they say that when I press S1, two things happen. The mains come on. Mains come on. Number one. Number two, centrifuge runs at low speed. Centrifuge runs at low speed. Let's move on. Now, when a push button S2 is pressed, the speed of the centrifuge changes from a low speed to a high speed. So when I press S2, the speed now, centrifuge now runs at what? Changes. Centrifuge now moves at high speed. As usual, I'll have a stop and an overload. So the stop is S0. So from here, I have everything I need here. Which of the following describes the main supply? Now let's see. We need an SR latch. We need an SR latch here. The output is the main supply. So what's the main supply? The main supply, the main contactor is Q0.0. So Q0.0 here. Now, what will make the mains come on? It is when I press the first switch. Because when you press the switch S1, the mains come on. So that switch there is start push button. That's I0.1. So I have my I0.1 here. What will make it go off? Same thing. Either when the overload trips or the stop is pressed. So overload and stop. I pass them through NOT gate. So the overload here is I0.3, stop is I0.0. So I have I0.3 here and I0.0 here. So that's it. That's it here. So that's for the A. That's for the A. Now the B, so let's check. So the answer is there. So the answer is this here. As we can see, this is the only correct one here. The overload must be noted, the stop must be noted. They go through an OR gate. And then when you press the start, the mains come on. So that's it here. The second question is, which of the following describe the operation of the centrifuge in low speed? Now let's see. Low speed. So low speed, right? So low speed, I'm sure it's Q0.1 here. As usual, we have our SR latch. So for it to move at low speed, what must happen? For it to move at low, you see that when you press the main, when you press S1, the mains come on and the centrifuge runs at low speed. So the mains must be on. So for it to run at low speed, the mains must be on. The mains must be on. And then, so this is it here. And the low speed switch must be off. I mean the high speed switch. There's a high speed switch here. There's a high speed switch here. High flowing. So let's see. So let's go to the answer straight. Right. So for it to run at low speed, you have to press the main switch, which is I0.1 here. Right. And also what must happen? Also, the high speed contactor must be off. So high speed is Q0.2. So it must be off. And then it will go off when the overload or the stop buttons trip. So you can see that one here. That one is always easier, going through an OR gate here. You can see it. So this will come on when what? When I press the main switch I0.1 and the high speed contactor is off. Because it can run at high speed and load at the same time. So high speed must be off. Press the mains, it comes on. And it goes off when the overload or the stop button trips. So that's it. So that's it for that question. So that's it for that question. Now, what make it run at high speed? what to make it run at high speed? One, the starting, it has to start, so the main has to be on. You have to press the switch here, right? Number two, you have to press the high speed switch. There's a high speed switch, that's S2, a switch that moves it from low speed to high speed. So let's see. And also the low speed contactor must be off. So let's see, let's think about it here. So for this to come on, three things must be satisfied, right? One, the main must be on, Q0.0, right? But the low speed contactor must be off. So low speed, Q0.1 must be off. And then you press the high speed switch. And then you press the high speed switch I0.2. I0.2. And then it will go off. What make it go off? When the overload or the main strip. When the overload trips or the stop button is pressed. So over here, you can see that this is the answer. This is the answer here. You must always find a way to think around this. This is a repetition of the low speed question, so we'll not look at it. Not look at it. So let's move on. Okay. Now let me explain this question here. Let me explain that next question there. So in that next question, you have a tank like this, right? You have a valve here. You have a valve here. Okay. So what we want to do is that we want to put a certain mixture into this tank here. Then we stir it and we drain it. That's what we are doing. So first thing, you press a switch. Let's call the switch S3, right? When you press the switch S3, what happens is that it opens this valve. When I press S3, the valve opens. The valve V1 opens. And it starts filling with the fluid. So it keeps filling until the fluid gets to this level here, right? So it means there must be a sensor that will sense the level. So there will be a full sensor. That sensor is full, S1. So as soon as the fluid gets to this region here, the brim of the valve here, the full sensor S1 senses it, and S1 initiates some actions. One, S1 will cause this valve to close so that the water stops filling. So the valve will close here. As soon as the valve closes, S1 starts a motor, right? That drives a certain mixture, that will mix it to stir this thing, to stir the liquid. Mix it for about 30 minutes. So the S1 does two things, right? S1 does two things. S1 senses that it's full, closes the valve so that, okay, don't fill again, then starts a mixer to stir this thing. And there is a timer set for 30 minutes. Now, as soon as the 30 minutes reaches, the motor is turned off. The mixer is turned off. And then the valve V2 will open to drain the liquid. So I drain the liquid until the liquid also gets to some minimum value. I don't want to drain everything. So here there must be some empty sensor. A sensor that senses that is empty. Let me call it empty sensor. Let me call it S2. So as soon as the water reaches a minimum value, the empty sensor senses it. Shut this valve. So it will close V2. And then now the water cannot go out again. Okay. Then there's a counter. So there's a counter too. It's a counter that counts every. So once I press S3, the process runs 4 times. So when I press S3, the valve opens, it's filled with water, it mixes, opens, is drained, then opens again, mixes, drained, opens again, mixes and drains 4 times. Then I can press S3 again for everything to continue running again. So that's the question. That's the question we'll be thinking about. So in the here we have everything. They told us what to use for what. They told us what to use for what. Kindly hold a bit. Pause. So let's move on. So which of the following codes describe the operation of the inlet valve V1? Now, the question is that when a switch S3 is pushed, the inlet valve V1 opens, right? And the reservoir begins to be filled with water, with the liquid substance. When the reservoir is full, the sensor S2 detects it and the valve closes. And a motor M starts working. So let's see. So now, so what makes it go off? It goes off. So let's start from what makes it go off. So it goes off when I0.1, that is the stop, is pressed, or when I0.1. Consider that as soon as the full sensor senses, the valve will close. So I0.1 is the full sensor. So as soon as the full sensor senses that it is full, it closes the valve. So that's how it can close. Now how will it come on? So come on under two conditions. One, we said that when I press I03, the valve will open. That one is there. When I press S3, the valve opens, right? Also, see, as I mentioned that the process runs 4 times, right? So, also, when I've pressed the I0.3 and the counter, M0.1 is the counter, and the counter has not finished counting, the valve will open again. Because I said that the counter must count 4 times before the process will end, right? So, this is here. So, when it come on, there are 2 conditions. Either of them. So either when I press I0.3, it will open. The valve will open. The process will start. Right? Now when the process ends, the valve will open again because it must run 4 times. So that condition is here. That condition is here. Is that when the I0.3 has been pressed and the counter has not finished counting, so I'll note it. Then I'll have 1 here. Once I have 1 here becomes 1. And we said it to go off when what? When either the stop is pressed or the full sensor senses. So that's it. So that's what was done. That's what was done. And then that's why the answer is D. Now let's talk of the mixer or the motor. The motor controls the mixer. Now we say that when the reservoir is full, this full sensor detects it. And the valve V1 closes and a motor starts working. So what makes the motor come on? The motor will come on when what? When the full sensor detects, right? So when the full sensor detects, the motor will come on. So let's see. So the full sensor is I0.1. So as soon as I0.1, that's the full sensor senses, this will come on. And what makes the motor go off? It says after 30 minutes, the motor stops. So the motor is controlled by a timer, right? So when the timer becomes 1, when the timer finishes counting and becomes 1, the motor will go off. Or when the stop button is pressed. So the mixer has 2 ways of going off. Either when the stop is pressed, as you can see, the stop must always be noted. You can see it here. That stop must always be noted. So stop is noted here. Or when the timer becomes 1, when the timer finishes counting, the motor goes off. The mixer stops mixing. Now the timer is set for 30 minutes, right? So the timer is set for 30 minutes. So which of the following is operation of the timer? So C and D are wrong because they are set for 30 seconds. You see the time here. So 30 minutes, 30 seconds. This is wrong. This is wrong. It has to be 30 minutes. So between A and B. Now what drives the timer is the full sensor. Because as soon as the full sensor senses, it starts the mixer and the timer starts counting down. The timer is controlled by the full sensor I0.1. So that's why this is the answer. Yes, so with these automation things, you must always think around the answer. Okay. Now, which of the following controls the output V2? We said that when will V2 open? 1. V2 open when the timer finishes counting 30 minutes. V2 must open. V2 open when the timer finishes counting 30 minutes. It will open. And V2 close when either the stop is pressed or the empty sensor. Because we said that when it's draining, when the empty sensor senses that it's empty, it should close V2. So that's it. So V2 close, V2 open when the timer becomes 1. When the timer finishes counting, V2 will become 1. Or it will go off when what? To go off when the stop is pressed or when the empty sensor is I0.2. So that's it. Then we can describe the operation of the counter. Now we said the counter is what? After every, so the counter must count 4 times, right? It must count 4 times. So if after the 4 times you've not pressed the start, it should count again. So that's it here. Okay, so here, so the drive to the counter is what? The drive to the counter is the output valve or the output sensor, because as soon as the empty sensor senses, it closes V2. As soon as the empty sensor senses, it closes V2, right? And then count it as 1. That's the end of the process. Yes. So there you have it. Now, also, what to set it? So the counter is controlled by I0.3. I0.3 is the start, at the start of everything, right? So when I start it, and the counter is not counting, it should count a 1. So that's it. So that's how. So the answer here is B here. The answer here is B. Okay. Then which of the following controls the operation of the lamp? The lamp. Say that the lamp what? The lamp should come on for the 4 counts, right? So here, the lamp will come on, which is Q0.3. The lamp will come on. So here the answer is B. Let's explain why. The lamp will come on when the counter has not finished. So for the counter running for the 4 processes, the lamp must be on. Okay, so it's on throughout the 4 processes. So when the counter has not finished counting, the lamp should be on. And the lamp will go off when I reset. When I press the start, it means I'm starting a new process. So it will go off and wait to start counting. So that's it. So that's it for that one. Let's look at this one and then we'll end this stream. We'll continue another time. Okay. So now here, let's see the circuit here. When I press the start here, I complete this line. So current can flow through line A. Current flow through line A energizes the CR. CR is a contactor or relay. Energizes CR. As soon as CR gets energized, all of its contacts reverse their position. What that means is that as soon as CR gets energized, this CR1 here becomes closed. It closes. CR2 closes. CR3 closes. CR4 closes. Okay. Now, as soon as CR2 closes, current can flow through this line B here. Right. So current flows through line B, energizes the motor M1 to come on, and T1, the timer. Right. Now, this is an... So the timer is set for 5 seconds, meaning that it's an on delay timer. Set for 5 seconds. Sorry. So after 5 seconds, this one also, so once a contactor gets energized, its contact reverses their positions. So after 5 seconds, this T1 will open, which means this motor will go off, and this T1 will close, which means current can now start flowing through this line here. Same way, this motor comes on, this gets energized. After 10 seconds, this will open, this will close, current now flows through here. So at the end of everything, so this procedure, what are we doing? We are saying that, okay, motor 1 should be on for 5 seconds, then go off. Motor 2 come on 10 seconds, go off. Motor 3 come on. So at the end of everything, motor 3 must be what will be left in the circuits. So should the following describe the operation of line A. Now let's see line A. For line A to come on, all these overloads must be connected. They must be on. So this must be 1, 1, 1. Right? And here it has two parts. Either when I press the start, so the start is what? The start is I0.1. So when I press the start, current will flow through here. Or when the CR gets energized and closes here, current can flow through it. So the current has two paths to go through. So here, the overloads are 2, 3, and 4, right? Sure. So here, 2, 3, and 4 must be 1. So there must be 1 here. So it means A is wrong. 2, 3, and 4 must be 1. So there must be 1. So let's see where. So between B and C. Now I said that also what must be on again? The stop 2 must be 1. So stop is what? Stop is I0.0. So I0.0 must be on here. So here there's no I0.0. So that's why this is the answer here. So the stop must be in the circuit. So it must be 1, 1, 1, 1 for current to flow through here. And then here I'm bringing an OR gate. And the OR gate will say that either when I press the start or when this get energized. So either start or energized. That is I0.1. CR1 is M0.0. So either the starts or the CR gets energized, and then all the others are 1. The motor, the line 1 will come on, or the motor on the A will come on. Now line B. Now line B, what controls it? What controls line B? So what controls line B? So line B is controlled by line B is this motor is controlled by this control relay. That's M0.0. Because as soon as M0.0 gets energized, this gets energized and this will close here. This will close. Once here closes, the current will flow through here. So that's it. And then it's also it will go off by a timer. I'm saying the timer is set for 5 seconds. Once the timer trips after the 5 seconds here, the line B will go off. Okay. So let's end here. In the next stream, we'll continue from this side. In the next stream, we'll continue from this side. Thank you very much.